Welcome to a tutorial for fitting two-dimensional Gaussian mixture models to a dataset. On the left-hand side you can see 3D visualizations, and you can see a colorful model, which is the Gaussian mixture model. The single colors denotes the components of the Gaussian mixture model, and the black dots are the empirical density estimation. You can switch them off and on as you wish to compare the model of the density estimation, and you can use the interactive three-dimensional visualization to get an understanding of the structures. You can see that the model is not a perfect fit on the data, because you can obviously see that it is too slim. The main axis is not long enough. On the right hand side, on the 2D visualizations, you can confirm this discovery. It also has not the correct angle. The app starts with an automatic initialization with an expectation maximization, for which there was identification of the modes was done priorly to the execution of the algorithm. And it uses 50 iterations to fit a Gaussian mixture model as a start for the app. The app provides a variety of tools so that the user can fit the model manual to the data. We are trying this out now. We see a root mean square deviation of almost 13%, and we can improve it at least till 6%. First thing, I would adapt the angle and prolong the axis. And also make it more slimmer. As we could see, the deviation is getting worse, so I'm going one step back, and maybe 7.5 would be appropriate. Not really. Alright, but with 1 or 2 clicks we already improved the error by 2 times. Now you can use the 3D visualizations to look at the model PDF. You can switch to the data estimation. You can switch on the data scatter and off. And you can use the two-dimensional visualizations to get a better understanding as well. You can take a look at the model density and at the data density and compare them with each other. For that, it is quite nice to remove the models, so the ellipsoids and the model's axis, and also to switch off the scatter plot or the scatter of the data. There's also a plot for the classification, which is a political map. On the scatter, you can compare the original classes with the classes computed by the model, and you can see an overlap for the original classes, and for the model classes a hard cut out to the bias theory. On the lower panel you can execute an expectation maximization. You can allow it to add or remove modes, or you can restrain the expectation maximization to the current number of modes, which would be 2 here. You can easily add modes with this button and remove the current one. Since we are like at the third component, you can just remove the third component. You can allow the classification if you haven't called one from the start. You can save the current setting here. If you have more than 2 features, you can switch them on the upper panel here. So you can change the setting during the running app or the app runtime and make multiple analysis. And on quit, the program returns all the variables required for a Gaussian mixture model. Those can also be used for calling the program again.